Okay, now we're ready. So first things first, we're now talking about the CSWP preparation exam, and I think it's fair for us to skip the about me section because I mean most of you already have known me from the previous one and the many other times that I've presented for this user group. But just in case you don't, here's a quick recap about me. I've been using SolidWorks for about 9 years now, and I've been pretty active in the community throughout the past couple of years. And this is part of what I do. I usually share my tips and tricks throughout user group meetings, whether it's about certifications or animations, which I'm also very passionate about. And the thing most people might know me about is my animation series, where I have a presentation called Zero to Hero that pretty much goes through the whole basics of animations. But we're here today for the certification part because part of my day-to-day job as well is to support SolidWorks users, and certifications are a great way for me to showcase my skills. And specifically this part is what we're going to be talking about today. Okay, so by the way, if you want like a deeper dive about my history with SolidWorks and how I started with it and so on, there was actually a coffee, a virtual coffee that I shared with Prasad here a couple of months ago. So it was like a podcast theme where we would just go ahead and he had some questions. So it was like a nice conversation between both of us. It's on YouTube, so if you want to check out the recording, you can scan the QR code and know a bit more about my history with SolidWorks, how I started to use it, and the other things that I do in the community as well. Okay, with that out of the way, let's get started with today's agenda. So we're going to start by talking what the CSWP is. We ended last session talking about the CSWA. Now we're talking about the next level, the professional level. We're going to introduce the exam to you, and then we're going to give some idea about what the exam covers, what kind of difference in level exists when it comes to the professional level of CAD design. And then we have some tips, and just a disclaimer, most of these tips will be things that you've already seen with the CSWA. Some of them will be new because once again, there's not a small portion, there's like a slightly large portion of the exam that's actually pretty much the same as the CSWA, just in terms of difficulty, it's a bit harder, but in terms of the content, the style, and therefore the things that you have to take into consideration or take in mind while taking the exam, these will pretty much be the same. And then we're going to, if we have some time and if there's anyone new here, we can also go through the virtual tester one more time, but it's pretty much the same software that we take the CSWA exam on. Okay, so with that out of the way, let's get started with what the CSWP even is. And just as we mentioned last time, the CSWA was Certified SolidWorks Associate. That's the title that you take after you pass the exam. Here we're talking about the CSWP, the professional level exam. And since we're now one step higher, it makes sense for us to also have the red part of the badge we see on the right slightly higher this time. So for the CSWA, it was like the lower third was covered in red. For this one, just so that you can visually understand that this is the higher level, it's now like 2/3 of the way. And obviously the expert, that's going to be all the way up till the end, okay? So what we mentioned with the CSWA is that it's usually meant to be for beginners, okay? But from what I've seen in the past couple of years is that sometimes the variation of the term beginners is a bit wide. So some would say, okay, maybe like a couple of months of experience with SolidWorks. I've seen people take the CSWA exam in like 2 or 3 weeks, 2 or 3 months of starting using SolidWorks. So it may vary greatly. So I'm not going to talk in terms of time time frames when it comes to the CSWP, but I'm just going to say that it's a well-rounded user. It's a person who has skills not just in one area of SolidWorks, but in multiple areas of CAD design related things. And we're going to understand that a bit more when we talk about what the exam actually covers. But just understand this: it's not just about a designer; it's actually a well-rounded designer, someone who has skills that are not just related to the design itself, but more also about the process of thinking about the design and setting everything up. Okay, and just as we talk about the CSWA exam, how important it might be and how useful it would be for you to get that exam, to prove your skills or demonstrate your knowledge, stuff like that. And that same thing also applies to the CSWP exam, just at a higher level this time. So yeah, this all would lead for you to better present yourself. If you're applying for an internship or a job, it's a better way for you, an easier or quicker way for you to showcase like the basic level of skill that you have. Okay, anything higher than that, that would be through hands-on tests maybe, or maybe it's going to be through the interview itself. But this at least should make it easier for you to get a place at the interview in front of a recruiter. Okay, so this is actually the definition of a CSWP certified person as listed on the CSWP webpage. So if you go solidworks.com/CSWP, this is what it says. It says each CSWP has proven their ability to design and analyze. This is the other important point, the analysis part of it. And when we talk about analysis, we're now talking about not just any regular parts. We're talking about parametric parts, that's fine, but also movable assemblies. And remember the word movable, because we're going to get back to that point in a bit. And it says that this is going to be using a variety of complex features, and this is what introduces the difference between this exam and the CSWA. So this is a bit higher in terms of level. Okay, so yeah, with that out of the way, let's get into the exam information. So as usual, we've already showcased this website before, solidworks.com/certification. You go there to learn more about basically any exam from SolidWorks. So in this case, it's going to be CSWP. You can also use the short link solidworks.com/CSWP. And if you scroll a bit down on the website, you would find a bit more information about this exam. Also, you're going to find some information about the sample exam. Okay, and you know, the information about the recommended courses, that kind of stuff. This is also pretty much the same for all. And then the maybe the most important thing here is that it's 2015 or higher to take this exam. I think for the CWA it was like 2011, but for this one it's 2015 or higher. So I'm pretty sure as well that nobody here uses 2015 or before. But just in case maybe you are, it's just a worth mentioning to take that into consideration as well. Okay. Okay, so with that out of the way, let's keep scrolling down. And this exam is a bit longer than the other one. The CSWA was 3 hours. This is 3 hours and 20 minutes. But as you can see here, it's actually divided into segments. It's not like a one sit through the whole exam. You can take it in like a 3 hour, 20 minutes whole exam at the same time. But you can also take it in 3 segments if you're purchasing it. If I'm not mistaken, the vouchers that you might take, those would usually be like a whole exam at once, so 3 hours 20 minutes at once. But if you purchase the exam, it's actually each segment is separate. So what I mean by that is that this is the first segment. There's also the second 2 segments. Each is like an hour and a half, somewhere around that. They all sum up to 3 hours and 20 minutes. So some of them are shorter, some of them are longer. Each one of them talks about a different topic or area of the SolidWorks professional level exam. But at the same time, you won't get the certification unless you actually pass all 3 of them. And this is actually a good thing and a bad thing, because if you take all 3 segments, well, if you, let's say you don't pass the second part, you can actually just retake that second part on its own. If you take it as like the 3 hours 20 minutes version of the exam, well, if you don't pass that exam, you have to retake the whole exam. So yeah, it's a good thing to have it divided into segments, because in that case, any segment that you fail, you can just retake that segment. You can repurchase and just retake that segment specifically, and that's pretty much it. And the moment you have all 3 segments passed, regardless of when you did that or how far it was between every segment and the other, you would get your CSWP certification issued to you. So I, for example, I didn't take them in order. I took I think it was like the second, third, and then the first, something like that. And that's fine. And I also didn't take them like right after each other. I think there was like a 6-month gap between my last take and the 2 before that, if I'm not mistaken. So yeah, that's also fine. As I said, the moment you take all of them, you get the certification. But also, when we scroll down a bit in the exam, this is really important part. This is where it tells you specifically what kind of topics and what commands inside of SolidWorks that you should be familiar with. And let me tell you that it's actually a long list. So this is not everything. It keeps going on and on and on. But remember, this is the professional level exam, so it makes sense for it to be a bit of a higher level, and not just like the basic stuff that we saw with the CSWA. Okay. And if you go through these, you're gonna find that a lot of them are actually just taken from the CSWA, and then you add to that some more topics that you would have to understand and use. So, for example, you see here it says standard mates and advanced mates. So in the CSWA, just mentioned standard mates. So that's the kind of addition I'm talking about. And there are things that simply were not in the CSWA exam that will be covered here. For example, it says here collision detection in an assembly. That's something that was not covered in the CSWA, but it is in the CSWP. Okay, okay. Now let's take each one of those segments and uh, like go through what that segment actually talks about. Okay, so first things first. When it comes to the first segment, this is pretty much like the CSWA CAD modeling and modification part. So no assemblies in this part, but it just focuses more about the CAD modeling stuff. Okay, but it's just dedicated to this part. So it's got like a couple of, I think it's like 12 or 10 questions, something like that. They are only about modeling and modification, modeling and modification. But unlike the CSWA, it's not like you design like 2 or 3 parts. It's just one part that you keep modifying and modifying and modifying and modifying throughout the whole segment. Okay, so as usual, the first thing to note is the questions themselves. Make sure to read the questions, because let's say if you like skip the design intent that the exam wants you to consider, and this is easier to understand by just reading the whole questions before starting to answer, it might be harder for you to design the model in a way that makes it easier to modify later on when you're required to modify the exam, the part. Okay, so make sure to use those two buttons at the bottom, the next question and the previous question, to just like get a better idea of what the exam is going to ask you to do with regards to modifications and designing and stuff like that, so that you can take that into consideration while designing the part, while creating your very first sketch, and so on. Okay, and remember, every now and then you will have like the exam giving you like a checkpoint where you would choose out of one of 4 choices, but after that you're on your own. You have to select the exam answer, or the question answer. You have to enter it manually in a text box like you see right now on the screen. So it makes sure for you to have like a checkpoint for you to return to, and to make sure that I'm still on the right path. I'm not off by anything. And if I'm off, I mean, I don't have to figure that out later on. These checkpoints make sure that you know that as early as possible, so that you don't mess up your next questions. Okay. Now, as we did with the CSWA exam, all you have to do it now is to set up everything properly. I prefer people starting with the units, whether you have templates for that or you would do it directly from within the status bar in the bottom right corner. And we're going to get back again to the status bar multiple times throughout the session, so remember that. So from there you can just change it as early on as possible. And we showcased, if I'm not mistaken, in the CSWA preparation session last time, what happens if you actually design something and then change the units. We showed that it doesn't actually like just remove the unit part and replace it with another unit. It actually scales the model up or down, or it just like as you would expect. It doesn't do that. It would simply just convert the value. So if you enter like 10 millimeters and you convert it into centimeters, the units, it's not going to be 10 centimeters. It's going to be 1 centimeter. Okay, no scaling is going to be done. It's only going to convert the value. So what you would have to do is to either add all your dimensions and values and stuff, or use the scale command as a sneaky way to like save some time and do it. Not that I've never done that before. Anyways, so now let's move on to the variables part. As I mentioned before, and this is the same thing with pretty much all the exams, where you hands-on part, where you're required to make use of some variables, global variables and stuff. Equations are optional, but global variables, these are a must, because at some point you would find yourself using the same variable, or at least variations of that variable, so the variable plus 2, the variable divided by 2, stuff like that, in different areas of the same model. So unless you've got like a super cool memory that you can remember it pretty much everywhere you use that variable and can go back to that place and edit every single time the variable itself is edited, it's better to just have everything set up in a single place and then modify it here. And when you hit rebuild or click OK, everything updates just like that. Okay. Uh, so now let's move on to the next part. The next 2 points, they are directly related to each other, which are also directly related to the design intent. So after you understand what the question wants you to design the model like, and what is actually going to be changed like in the next couple of questions, this is where you decide what kind of course of action is the best. We also showcased in the previous session like the cylinder, right? We showed 4 different ways to create a cylinder with an extrusion, with a revolve, with a sweep, and even with a loft. And we mentioned the differences between each one of those, which is quicker, which is slower, which would require less sketches, which would require more sketches, which would require you to use the exact same dimensions that are given to you in a design print or in a drawing, and which would require you to do some mental math to come up with the values that you would use to fully define your sketches, and so on. So it all comes down to your preference, it all comes down to your knowledge, which is the best course of action to design something as the exam will want you to be. And speaking of fully defining sketches, this is the next part. So we also mentioned that there are multiple ways to verify that your sketches are fully defined. And as Tutor Toby mentions, you got to fully define every time. So if you go back again to the status bar on the bottom right corner, you're going to find it saying underdefined or fully defined or overdefined, whatever the status might be. I don't think we actually covered over definition in the CSWA preparation session, but yeah, if you guys know the over definition, or ever had an overdefined sketch before, that's when you give the software a bit more information that it would actually require. So if you give it more information that it needs, it would tell you that it's actually over-defined. If you give it less definition than it needs, that's under-defined. And if you give it just the right amount of definition, that's the fully defined. Okay. The other way to also just visually understand if this is a fully defined or underdefined sketch is also from the from the feature tree. So the feature manager design tree it's usually in the software, it's usually on the left, but I'm trying to confuse you today, so I'm putting on the right. So if you find this minus sign between 2 brackets before the sketch name, that's an underdefined sketch. And if you don't find that, that's a fully defined sketch. And guess what? If it's overdefined, it's going to be a plus sign between both brackets. So that's pretty much the visual way. And I remember people mentioning in the comments last time a third way to determine if your sketches are fully defined or underdefined or what. So let's see if people are still paying attention this time. If you also know a third way to do it, let me know in the chat. If there's a third way that you know, other than the status bar and the design, the feature manager design tree, a third way to like visually realize if your sketches are fully defined or underdefined. Let me see in the chat. Okay, while you enter that in the chat, I'm going to go on to the next point, which, as I mentioned, it's directly related to sketches, which is the features. So basically, when you create something, you have to usually create it from a sketch. I mean, I've came across a feature that would not require you to design with a sketch, but it was a very advanced thing and a very silly thing to actually use inside of a real design. So I'm not going to consider that, and I'm going to go with the assumption that pretty much any design starts with a sketch, then a feature. So in that case, the main thing here is to take your time. Remember the example that I mentioned earlier, the one where we create the cylinder in 4 different ways. Well, that's the thing. It's good to take some time. I know that 3 hours and 20 minutes might not sound like much, but you still have time to take a break and think and go and get a glass of water and take a sip like I'm going to do right now. And then just make sure that whatever you're going to start with, it's actually the easiest way for you to modify later, or the quickest way that you know, or whatever it is for you. But the main thing is you have to not just do it because this is the first thing that you thought of. Okay, it might be right, but it's probably not going to be the best option. um, and this all comes down to, once again, the design intent, what the exam would require you to change or modify later on. Okay, so how about this? Let's do a hands-on test real quick. Okay, so usually design in front of an audience. So this is going to be a new thing. Okay, this is obviously not taken from real exam, because for the keen eye of you, if you like take a moment to read this question, you will notice that there are many things that this question does not mention. Therefore, the design is not like there's one design that's going to be correct. There are like multiple options that can be correct in this way. Obviously, a real exam question would not be as vague as this. It's definitely going to be more precise, more strict, so that there's only one design that you can create that would fit those criteria. But as a fun example as well, let me know in the chat if you understand, or if you have found out what kind of information is missing from this question to make it actually foolproof. Okay, and by the way, I see multiple people in the chat mentioning the colors. Yeah, sketch colors. So when it comes to fully defining sketch, if it's black, that's by default the color for fully defined sketches. By default, blue is for underdefined sketches. Over defined, it depends if it's like an error or just a warning. So it's probably going to be yellow. Red is for like the bad stuff. So yeah, many people got it correct in the chat. That's good. So now let's check this question. It says, let's create a 100 by 100 by 20 block with a 15 millimeter diameter through hole located at a third of the block's width and the fifth of its height. Okay, so 100 by 100 by 20, 15 diameter through hole, and third of its width and fifth of its height. Here is SolidWorks. Let's start a new design. Okay, and I'm going to go through what I do. I'm right now, you can't see my face or anything, but I have my hands, both hands on my keyboard, with my thumbs resting on my touchpad, because yeah, I'm using a laptop with no mouse right now. Okay, and for that, I've pretty much created a workflow that works for me very well, that makes the most use of my hands being always as close to the keyboard as possible. So in that case, I don't really use mouse gestures, but I've got a lot of keyboard shortcuts that I will be using today. Okay, it looks like my design is starting at a good pace. So SolidWorks is taking its time to create a new part. While it takes that, it's a good tip as well to consider, to right click on the command manager, go to customize, and then play a bit over there. Okay, find the best workflow, or the best environment that you prefer SolidWorks to look like and to act like for you. This might be just like some customizations to your command manager, to your toolbars, to your menus, or even take it the next level and start modifying the keyboard shortcuts, adding new, modifying existing ones, stuff like that. And if you're a mouse guy, or a mouse gestures guy, then by all means do that. You can use like 2, 4, 6, or even no, that's not 6. It's like 2 or 4. I think it's 8 and then 12 different mouse gestures on your mouse. So those are like 12 commands at your literal fingertips. Okay, and SolidWorks is a bit angry today, so you know what? Let's close it and launch it once again. Okay, I mean, what kind of hands-on demo doesn't start by SolidWorks crashing on us? Yep. Yeah, that was what you expect when you on the whim decide to design in front of an audience. But yeah, hopefully this is going to be like the longest we have today. Okay, but let me check the chat to see if any. Okay, Prasad is saying, trust me, he uses trackpad better than many mouse users. I'm an eyewitness. Yeah, I actually. So, fun fact for you guys who don't know this, I actually went like on a duel or a battle against Prasad, a CAD designing battle through the Experience World earlier this year. And he was using a mouse. I was just using the touchpad, and I won. So that's that should be an indication in case you're wondering. But yeah, I've been using a touchpad for years, literally. Pretty much all of those years that I've been using SolidWorks for, I've been using it just with a touchpad, no mouse or anything. Just lately, I started messing around with using a mouse, using Space Mouse, just to try out the new different configurations and to figure out if it's going to be a bit better for my workflow. Still, my go-to workflow is just with a touchpad. I don't have any of those, whether it's the mouse or the Space Mouse on my permanent setup yet, just yet. If they do go up to the level or the standard I have for myself in terms of speed and ease of finding or reaching commands, maybe they will, and I'm definitely going to let you know if that happens. So anyways, we took a lot of time. Now let's start. So basically, as I mentioned, we usually start with a sketch, and then you start with the you do the feature after that. But obviously that's incorrect. We first have to start with the units. Well, thankfully I already have the units set up to be millimeter, gram, second. For this question, I didn't mention any materials, so that's going to be fine. If I did want to add a material, I would do that. I would prefer to do it straight away. It's not really going to change anything when you do it now or when you do it later, unlike units, for example. But it's a good thing to like divide your design process into like phases. You have the setup phase, you have the designing phase itself, and so on. So in the setup phase, you set up the materials and the global variables and the units and everything, just to make like a mental checklist for yourself. Anyways, let's get started. So even though I mentioned that we're going to start with a sketch, I'm actually going to do something different. I'm actually going to start with the feature itself, because from my experience with SolidWorks, I know that if I start with a feature that needs a sketch, it's actually going to prompt me to design a sketch. And then when I do the sketch and exit the sketch, it's directly going to push me back to the feature that I started with. So it's just saving me a couple of clicks. Okay, so let's start with the front plane. And I'm using SolidWorks 2025 SP3, the latest edition right now. So I am using a feature that's quite new, which is to create a square from the get-go. So for example, I can go to the rectangle tool from my keyboard shortcut. If I do like this, it's a center rectangle. As you can see, this is my most favorite type of rectangle. And you can also say that I've slightly modified it. It has center lines that are from midpoints, from corners. So usually it's this option where it goes like this from corners. And the reason I changed this is because when I wanted to create a square, I would have to like select these two corners, and then I have to deselect this center line just to give this an equal relation. Well, no longer if I go once again to the rectangle, but change this to midpoints. If I do it like this, now all I have to do is just box select these two. Nothing's in the way. I can directly make it equal. But guess what? SolidWorks has taken it one step further, and now directly from this rectangle tool, regardless of which rectangle tool it is, if you just hold Shift on the keyboard, it now snaps into a square. Okay, so now when I add it, as you can see over here, it already has this equal relation. So it's now a square. All I have to do now is also use my keyboard shortcut to get to the smart dimension tool, enter the 100mm dimension, and that's the first thing. Now the next thing is the hole, the through hole. It was like a 15mm, so I'm also going to do that also from my keyboard shortcuts. So the circles from my keyboard shortcuts, dimensions from my keyboard shortcuts, even the rectangle, everything is from my keyboard shortcuts, because these are the things that I use on a very, very regular basis. Okay, so now let's talk about the next thing. I need to define where this is inside of this square. It has to be the third of the width and the fifth of the height. Okay, so let's get back again to dimensions. Let me put this like that. Okay, and now if I just go ahead and select this 100, and then say divided by 3, I mean, that would work, but the issue here is that it's not actually a fixed relation. So if I go to this 100 and make it 120, does that 33 become 40? No, it's not, because this is like a one-time use case thing. But if I want it to be maintained, I have to make an equation, enter equal, select this, and then divide it by 3. Now I've got this equation mark over here. So that shows that now if I change this 120 to 100, it's now also going to change the 40 to 33.3, as you can see over here. So this is one way to make it. There are multiple ways you can use. The other way is, so I have this 100 and I want to make it divide it into 5 sections, so I can put the whole at the fifth of the height, right? So let's try another one. I've actually found this. You know what? Let me just take a pause over here. I found this cool feature that's hidden away a while ago. So let me like draw a line. Let me draw like an arc. Let me also draw like a spline, just for fun's sake. Okay, so this feature would work on pretty much any of those. It's called the segment command. I put it over here in my features on my command manager, but the right way to find it is to go through here. I think it's tools, sketch tools, and then segment. It's yeah, over here. It's very hidden away that it's really hard to find it yourself unless you're actually looking for it. Fun fact, I was actually going to submit an enhancement request for a feature that would do this. Just as I was about to submit, I just decided to search if anyone has submitted anything like it. And that's when I've actually found that this feature actually does exist. So yeah, so what it does basically is it divides your entity into segments. So I can divide it into points as this. So it would add like 5 equidistant points on my line, as you can see over here. The line is as it is. It just added 5 points along its length. And if I increase or decrease the length of the line, so let me fix it from 1 point. If I increase or decrease the length, the points would also follow. It works also for arcs. I can do the same thing for an arc. Instead of points, I can also divide it into segments. So in this case, it's going to actually create 5 different arcs that are all co-radial to each other. So here's one arc, second arc, third arc, and so on. And all of them are co-radial, and they also have this equal curve length relation. The same thing is also applicable to splines. I can divide it into multiple splines or add some points along the spline as well, as you can see over here. So yeah, that's so cool. Now let's try and use that in our design over here. So what I'm going to do is I'm going to start by sketching a center line, which guess what? I also have it from a keyboard shortcut. And what I would like to do now is to divide this center line into different segments. So in this case, I can go with, let's say, 4 points. Okay, well, why am I going with 4 points? Because if you're going with segments, that means that you need to have the exact same number, because as you can see over here, it's 1, 2, 3, 4, 5, right? But if I go with points, okay, and leave it as 5 points as it is, you're gonna notice that it's actually 1, 2, 3, 4, 5, 6, because it adds 5 points, not creates 5 piece of a line. So in this case, I would actually need to reduce this by 1. Now, if I just attach this to this point, I am good to go. It's now the third of the width and the fifth of the height. Okay, so with that out of the way, now when I exit the sketch, it automatically remembers, hey, you started the sketch from a boss extrusion. Now let's get back to the boss extrusion. And now all I have to do is just go with a 20 millimeter as the question stated. So it was 100 by 100 by 20 block. I had the 15 through hole. And that's pretty much it. So now I also have a keyboard shortcut for my mass properties, so I can check, and it's this value, 196.47 grams. Now let's go ahead and check if that's correct. It's indeed 196.47 grams, and congratulations to me. Looks like I am qualified to take the CSWP exam. Just kidding, because as I mentioned, this question specifically has a lot of vague areas. So let me see if anyone caught up on any of those in the chat. Let me see. Let me see. Yeah, we actually did. So Abdullah Ghalib, he says which side to start at. That's correct. So I never said that I have to start from like the left or from the right, or the fifth should be from the top or from the bottom. Because if I go back again to SolidWorks and look at the model from over here, well, what stops me from doing this over here? So it's going to be the fifth from the left, but the third from the bottom, or maybe over here. So the fifth from from the right, and the third from the bottom. Oh, maybe over here. So it's also going to be the fifth from the top, but in this case, it's going to be the third from the right. So what stops me from doing that? I've got now 4 different cases to design this. So once again, you're not going to find anything that vague in the real exam, but this is just to showcase the time and effort that's put into something like that to make sure that it's pretty much design proof or like foolproof. Okay. Anyways, let's get back and see if anyone has any questions about this part. Okay, we have some people saying here, can't imagine doing this with a trackpad. Well, guess what? I just did. I just did. So yeah, I've been doing this for quite a while. So I do have a lot of practice with it. I'm sure that if you also give yourself some practice with it, you'll also be able to do it. Ahmed Abdelmanem, you're mentioning no material. Yeah, because the question didn't mention material. Once again, this is my questions. As I said, they're missing a lot of information. The point here is not to mimic a real exam question. It's just to showcase a typical workflow that I would usually go through. Okay, so that takes us to the next part of the first segment, which is modification. So just as the CSWA exam, we either add or remove features, or we simply just edit global variables. And by the way, nothing stops the question from asking you to do both. You can both change the variables and also add and remove features. So it's really important to check the variables every single time, because sometimes you would think, okay, it's asking me to add some holes or maybe remove some material and stuff. It's definitely not going to ask me to do anything else. But later on, you realize that it actually did ask you to change the variables as well, but you just were too busy changing the model or changing the features than paying attention to the variables values. So yeah, that's a good thing to consider. Now, here is a good example for why you should always read the whole question and also the next question and the next question and so on before you start answering the question. So now let's modify it. The modification is saying make it 150 by 200 by 30 block and add a 20 millimeter in terms of diameter and a 10 millimeters in terms of depth hole located at the fourth of the block's width and the fourth of its height. Now, here's the thing. I'm not only going to be modifying the width, I'm also going to be modifying the height and length as well. And I'm going to change the diameter. I'm also going to change the end condition of the hole and the placement of the hole. Okay, so these are multiple changes as well at the same time. And if I had known that I would do all of these, I would have modeled the part at the beginning in a totally different way. So let me show you why. So for example, if I want to modify the length and width of this, like in this case, it's going to be like the height and width of this block, I can just do a single select over here, and this, because I have instant 3D turned on, I can just simply select this 100, make it a 200. Same thing for the height and change it from 100 to 150. But remember, I added the relation between both of those. Relations can't be edited from outside. I have to actually go through and edit the sketch itself in order to do that. So had I known that I would later on change it from a square to a rectangle, I wouldn't have added this as an equal relation, and I would opted for a separate sketch or a separate dimension for each of those, just so that I can, from the get-go, just change what this is going to be and what that is going to be. Anyway, since we're already in here, let's also change this one. So this 150, I think this would be 20 if I'm not mistaken. And then this third from the width is going to be a fourth. So I'm just going to change this 3 into a 4. That's fine. And cool thing, I actually don't have to modify much when it comes to this segment, because cool thing about the segment is if you delete one of these points, it's actually going to like reorient itself or repattern itself, and then just now instead of having 4 points, it's now going to be only 3 points. In this case, it would automatically space those evenly as well. By the way, if I had went with the other option, if I had went with the option to go with the segments instead of points, so 5 sketch segments, here's a cool thing to notice. So let's say, for example, I put this circle over here. Okay, let me just turn these relations off for a moment, even the sketch dimensions. Let me just zoom in a bit. And now, so if I decided to, let's say, delete one of these and then add the relations again, you notice what happens over here. The collinear relation that I had that made this and this at the same along the same line, and the same for the ones before, it was between this and the one that I deleted, and it was between the bottom one and the one I deleted. So these two are now not collinear. So this is an extra relation that I have to add just to make sure that it's working. There's obviously a workaround for this, because from experience, I also know that I can delete the bottom one. And in that case, nothing is going to go wrong. I can simply just drag this and everything is going to work just as I expect. But the same thing, do you want it to be a two-step process, or do you want it to be a single-step process? So it all comes down to what you're most familiar with, as well as what's the quickest course of action if they're both equally going to give you the design intent that you require. Okay, so these are all things to consider. Okay, and once again, these all come from experience. I don't think that I've ever had like a like a YouTube video or someone in a user group meeting mentioning the segment tool. It's something that I've researched on my own and found out about it, and I started using it, and then from using it a lot, that's how I found out the things that I'm telling you about right now. So this can also be applied to pretty much any other feature as well, not just the segment tool, but I'm just giving it as an example of why having these like deep dives into some of these commands would be helpful later on. Okay, anyways, let's exit the sketch, and now we want to modify the size of this. So instead of like being 20 in terms of depth, it's only going to be 30 this time. So I can also change this without even needing to change the feature, because once again, I'm using instant 3D, which is showing me all these dimensions by simply just clicking on the model. But the other thing is, now that I want to change this hole, I've got multiple options. I can like select the hole and do a boss extrusion to fill it up from the end, maybe, or maybe I can like delete this face and delete this hole and add it once again. There are multiple options. The best option would be to actually stick to the dimensions that I'm given. So I was given a depth dimension. I don't want to subtract that from the depth of this extrusion and do mental math to figure out how much I should fill the hole. I shouldn't be filling holes. I should be creating them. So in that case, I'm just going to do it in two features. The first feature is just like this, and then I'm going to reuse the sketch to do an extrude cut with just that hole. So from the selected contours here, I'm just going to select that hole. But in this case, let's start from this face, go inwards, and now I will enter exactly the dimension that I'm given. I think it was what, 10? I think it was 10 or 15 maybe. I think it's 10. We're going to figure out in a moment when we check the answers. But anyways, now I am sticking to the dimensions that I'm given. I don't have to say, okay, this is 30 minus 10, that's 20, so let's fill it by 20. You're not supposed to be doing things like that, especially in an exam. That is going to give you like a good model in terms of the dimensions and everything, but modifying something like that in the future is going to be a bit tedious. Even if you do it with an equation, it's like an unnecessary step. Okay, so now let's check the mass. So now it's 896.86 grams. What do you guys think? Do you think I would qualify for the CSWP? Let's see, 896.86. It is indeed. So yeah, I would give myself a pat on the back, and looks like I am good to go when it comes to segment 1. Let me see if there's any other questions in the chat real quick about this point. So we do have some. So we have a question here by Muhammad Ashfaq Hussein. He's mentioning, without material, how can we measure mass? Well, any part inside of SOLIDWORKS has a default density, and given that you already have a mass calculated, that also means that that default density is used for pretty much any model that does not have a specified material setup. So pretty much for a mass to be calculated, you need two things. You need density and you need volume. Volume is created from your model itself, or calculated from the model itself, and density is usually going to be obtained from the material. If you don't specify a material, in that case, it's just going to set up an arbitrary like value for the density and use that for the calculation, and that's what it does in this case. Okay. Okay, so we have another question from Muhammad El-Asi. He's saying, why don't you take the 20 millimeters as the height? Once again, the question is open for pretty much any interpretation. Once again, the real exam question is not going to do something like that. So what you're mentioning, I believe, is to, instead of doing it like this, you would expect it to be something like, let me see. Yeah, something like this. So the 20 will be the height instead of the depth, right? How I interpreted it is it's going to be X, Y, and Z. So 100 by 20, that's 100 in X, 100 in Y, and 20 in Z. So when I put it like this, it follows along. The same thing when it says make it 200 by 150 by 30, I also put 200 in the X, 150 in the Y, and 30 by Z. But once again, since I don't have any images in the question, and since I don't have anything in the question to specify exactly where each one of those should go, I'm free to use any orientation. Now, is a real exam question going to do that? Obviously not. It's going to give you images so you can reference the images. It's also going to be a bit more specific when it comes to something like that. Now, notice something as well in an exam question, which we will check an example of at the end of the session. It's usually going to say the origin, where it should be, and that's what's going to tell you, okay, how the orientation is going to be like. The origin is either going to be specified or it's going to be arbitrary. And if it's arbitrary, then it's fine, because that's not going to affect the mass of the model. It's only going to affect the center of mass, and that's usually going to be only with assembly related questions, not part modeling questions, and there are no assemblies in segment 1. So that's also something to consider. Okay, there's no right and wrong about what the orientation is going to be, but it's just easier for you to make stuff in a certain way. Let's say, for example, you want to mirror stuff about, so it's a good thing to make sure that your origin is in the middle, because let's say, for example, I want to mirror this hole to the right. I can just do this because I already have my right plane in the middle of the model. I don't have to create a new plane and set it in the middle and stuff like that. Okay, I can use or reuse these three planes that I have over here. And I can just directly go from here to this and then do a mirror and just call it a day. If I didn't have the origin over here, as most people I see would actually do, they tend to put the origins in the corners. So for a sketch like this, instead of putting the origin in the middle, they would have this point and this origin be the same. Now, I don't prefer that. I always like to have my models symmetric, so that if in the future I do need to do any mirrors or patterns or anything, I would already have these planes for me to use. Once again, it comes down to personal preference. Both of them would be fine. One is quicker, and one would require you to create an extra sketch or an extra plane or something like that. So these are all things to consider as well. Okay, let's see what other questions we have. How to know the time to use function and the time not to use it? This is a question from Abdul Wahab Suna. I think what he's mentioning by function here, equations. There is no like a one answer for all cases. It all comes down to are you going to reuse this in the future or not? Is this something that would be modified in the future, so it needs to always maintain that value, or not? If it's just set up for one time and that's pretty much it, it's fine to just enter a dimension. If it's going to be directly linked to that value, so that if the first value grows, this grows as well. If the first value shrinks, this shrinks as well. In that case, it would make more sense to make an equation. Sometimes I even set up equations for things that would be set up once, just for me to remember how I calculated it in the first place. So instead of like writing a note or adding a comment to the feature, saying that this was designed so that this should be half this or this should be quarter of that, and so on, I would just do it as an equation, so that when I come back to the model later on, I look at the equation and understand the logic behind setting it at that specific value. Okay, so it all comes down to personal preference. And let's see what other things we have. So we also have someone here mentioning points much better than using segments. Well, not always, because sometimes you would actually need to use segments. Not always. Our points are easier. Not always are you going to go back again and modify a segment. So yeah, it's not always the better. For example, I prefer segments than points usually, because when I have a segment, I don't really divide the part by the specified number. I actually have twice as much. So let me show you how. So if let's say I go to the front plane over here. And by the way, all of this is also doing keyboard shortcuts. The sketch, the normal to moving things around, that's all by keyboard shortcuts. Even moving the model around, I do that by the keyboard. But anyways, here's the line. Okay, let's divide that into segments. So let's go with sketch segments. Okay. Now you might think that I have 1, 2, 3, 4, and here's 5, and here's 6 points along that line. But in reality, I have much more than that. So let me show. So I actually have a point over here. I have a point over here, and a point over here. I have a point over here, 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 and finally over here. So that's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different points along this line. Because since it's a line that is divided, I can also make use of the center points. So right here, if I select the center point of any of these lines, that's an additional point. Now, center points are really useful if you want to make things like going to be equal to half something, or maybe in the middle of something. I would use those a lot, instead of dividing into 2 lines, making both of the lines equal, and then just using the endpoint between them. So these are all different ways to do it. If I'm using points, well, it's all going to be one line, so I don't have any extra mid, unless the one of the main line in the center. So yeah, it all comes down to personal preference once again. Okay. Okay. Let's go back into the presentation, because I don't think we have any more questions right now. Okay, so with that out of the way, now let's get talking about segment 2. Now, segment 2 is totally different from what you would expect in a CSWA exam. It's not included in it whatsoever. So now let's see why. Because segment 2 is talking about a couple of things. It's talking about configurations, and it's talking about design tables. And just for you to understand the difference, design tables are one way of creating and modifying configurations. So the main thing that you need to learn and understand and use is configurations, and then there are multiple ways to change them and modify them and even create them, including design tables. Whether these are design tables created directly inside of SOLIDWORKS, or created by configuring a feature or dimension, or even created through Excel. These are all different and valid ways to create something like that. So for you to master something like this and make sure that you're ready, you must learn a couple of things. The first thing to keep an eye out on is design intent. You must realize and understand what design intent is, what's the design intent of the model that you're presented with, and so on. These are very, very important concepts to consider, so pay close attention. The second thing you have to master is design intent. The third thing is also design intent, and the fourth thing, which is this is the thing that you must apply a lot on, is also design intent. And finally, you must check for lots of resources also on design intent. And when you finish all these 5 points, you should also learn more about design intent, and you should follow up with design intent, more design intent, and a bit more of design intent and design intent. Okay. Now, why am I saying design intent a lot? Because this is pretty much the only thing that you should focus on when it comes to this part. Yeah, you should learn how to create configurations and how to make some design tables. But if you don't understand the design intent of the model that you will have, this is what you would end up with. And And I'm going to steal a phrase that I heard another community member say, ketchup and mustard. Well, it's good to have it on your hamburger, maybe good to have it on a hot dog, but it's definitely not good to have ketchup and mustard, or in this case, errors and warnings in your feature tree, right? So yeah, basically, if you want to avoid this situation, understand the design intent. Now, what segment two is basically going to be about is you're going to be given a couple of models. You will be required to understand the models, how they were created, why they were created in this way, and then modify them, or maybe create some configurations for them. Maybe delete some configurations and figure out what changes you introduced, or changes you added to the model because of something like that. So these are all different things that might happen in this part of the exam. So that's why I'm really focusing on and emphasizing the point about design intent. If you don't understand how the model was created in the first place and why it was created in the first place, you won't be able to change it later on or configure it later on. Because here's the thing, we all are very good designers when we come back again and modify our own designs, but not that good when we modify others' designs. When we are given a design created by someone we've never met before and we're asked, hey, modify this, it usually takes us some time to figure out how the model was created in the first place before jumping in and modifying it. So this is the base of this whole segment. Okay, now there are good tools for you to consider and use and stuff like that. Something like the child and parent relationships, understanding the cause and effect of pretty much every single feature in your feature tree. So this is a feature that would pretty much list anything that affects or is affected by whatever it is that you selected. So if you select a sketch or a feature, or maybe even a reference entity, a plane or an edge, sorry, a plane or an axis, stuff like that. All of these are affected by something and affect something. Okay, so let's say, for example, you create a feature from a sketch. Now that sketch controls the feature, and that feature is affected by that sketch. Same thing goes on if you add a fillet to a boss extrusion, for example. Now that fillet relies on the boss extrusion, and the boss extrusion affects how that fillet is generated. So these are really important things to consider, because we've all been in that situation where we suppress or delete a feature, and then half of your feature tree goes along with it, and you have no idea why that was deleted as well when you only deleted one feature. Well, the thing is, it's the child and parent relationships. So if you right click on any feature or any reference entity and go to child parent relationships, it's going to show you a dialog box like this to show what are the feature's parents and what are its children. The parents are the things that affect it, and the children are the things that will be affected by it. Now, there's another way, which is to have things shown to you in a dynamic way like this. So all you have to do is just hover over the feature, and it just shows you these super cool arrows that go upwards and downward to show you the parents and the children of every feature. So if I jump over here into SolidWorks, right now, if I hover over any feature, I don't see anything. I can right click and go to child and parent to show me the child and parent relationships. But if I want to activate that feature, I can do that directly from my feature tree. So this is a command that you can activate and use. Okay, so if you go over here to the very top of your model, okay, over here you see dynamic reference visualization parent and dynamic reference visualization child. Now you can also search for it over here. So if you go dynamic, so there it is, child and parent. And if I click this eye, it's going to show you exactly where it is located over here. So it's in view, user interface, and all the way over there. Okay, and as you can see, I also have keyboard shortcuts set up for it because I use them a lot. So these are my keyboard shortcuts. You won't find them over there by default on your device, but feel free to go and add them. So what they would do, so let me turn on the parent, for example. If I hover over any command, as you can see, it now shows me that, hey, this one has 3 parents. It has the origin, it has the sketch called sketch 1, and it has post extrusion 1. If I hover over this one, it tells me that, hey, this is affected by the right plane, and it's affected by affected by cut extrude 1. Okay, if I do the same thing for parent, as I did. I'm going to do the same thing for children as I did with parents. So now this tells me that, hey, cut extrude 1 is the child of bus extrude 1. Cut extrude 1 is the parent for mirror 1, and so on. Origin, for example, it affects other things, and so on. This can also work for sketches. So let me turn both of them, child and parents. So for example, sketch 1, its parents are the origin and the front plane, which it's sketched on, and its children are the cut extrusion and the boss extrusion, which are created from it, and so on. So these are multiple ways to verify the links or the relations between these features and each other. Okay, and by the way, as your feature tree gets longer and longer and bigger, you might end up with something like this, where you would find hundreds of features and sketches affected by something. Now, this is a case where in that specific scenario, it's better to use the dialog box than just this visual, dynamic visual indication. Because it's easier to manage and easier to go through. But yeah, I'm just putting this out there for you, because this was one of my biggest models. As you can see over there in the solid bodies folder, it has 1,205 solid bodies. And I went all the way to the very first feature, boss extrude 1, to check how many references it affects, or how many children it has. And as you can see, it's got loads of them. Okay, so yeah. Sometimes it makes more sense to use the dialog box to scroll through those in a better manner. Okay, and now we're going to go through with segment 3, the segment of the exam. Let me just check if there are any questions about what we just mentioned here. Yeah, Prasad is saying, this kind of screen makes me want to throw away the laptop. Yeah, I think he's talking about the ketchup and mustard. Hey, you don't like ketchup and mustard? Come on. But yeah, I understand, because
it's not that I don't like it, but if someone else sends me a design to check, that makes me do it.
Yeah, we've all been there. No worries. Once again, it's not that you should avoid having errors. It's that you should avoid having errors you can't solve. At the moment you have an error or a warning that you don't know why it's there or how to solve it, that's when you have a problem. Because I'm talking from my experience, and I'm pretty sure many can relate. There are some times where I would delete something or change something, and I know 100% that the moment I hit confirm or OK, I will be shown an error message. But I know that error message, and I know how to solve it, and I just don't care right now. I'm doing something, and then I'm going to go back and solve that error message. I like deliberately create that error message for a higher or a ulterior motive that I know. And that's fine. But what's not fine is that when the software like surprises you with, hey, you've got like 10 errors that you haven't solved yet, and you're like, okay, I have no idea why they are created, why they show up, and now I have to go and stop designing and start troubleshooting. So yeah, that's not the best scenario you want to find yourself in, but it's a scenario as a designer you will always find yourself in. Okay, let's see what else. Okay, just some general questions that we could check out at the very end of the session. So now let's keep going with segment 3. Now, segment 3, the final segment of the exam, in case you try to take it in order, segment 1, then 2, then 3, this is now the segment about assemblies. Now, this is very, very similar to what we saw with CSWA, with very slight modifications or enhancements. So let's see. So it starts by the regular stuff. We first have to make sure that we set the origin correctly, and as we mentioned earlier in the CSWA preparation session, and also earlier in this session, when it comes to the origin, it's either going to be mentioned or going to be set as arbitrary. Usually in the assemblies, it is actually mentioned, so you have to make sure that you apply that correctly. The easiest way is to not set your like components to be float by to be fixed by default. Make sure you try and set them to be floating. In that case, you can move them around after you add them into your assembly. Otherwise, they will be fixed in place, and you won't be able to change their position or orientation. I actually have the setting to to set them to be float set by default for all components I insert, not just the first component or anything. So no components of mine are fixed ever, but that's also a personal preference. So yeah, I advise you to do the same if you would like. And let me also show you where that is in case you don't know. So now let's create a new assembly. Okay, and the first thing it asks you to do is to insert a component. Let me just not do that right now. And if I scroll all the way down here, let me just zoom in a bit. And as you can see, uh, fix/float components on insert. Okay, so yeah, this is the point where you would most likely want to set it to be fixed or float or only fix first component. I prefer float, as I mentioned. Some people would set it to only fix the first component for some reason, no idea why. I prefer float just to make sure that everything is set up the way I like it to be. And by the way, if you do set it to be float, in that case, you now have to fix the first component with mates, right? So I would always use a coincident mate between the origin of the first component and the origin of the assembly, unless the question once again asks me for a specific orientation. In that case, I would do that. If not, this is my go-to scenario. Insert a component, it's already float. Now let's add an origin coincident mate, just to make sure that everything is not going to be moving and everything is fully defined. As I also mentioned, between origins, we have this extra option called align axes. This checkbox you can see in the property manager over here. And this would make sure that the x-axis of the first origin and the x-axis of the second origin are aligned. Same for the y-axis and the same for the z-axis. So pretty much you have the front planes on each other, the right planes on each other, and top planes on each other. So it's basically like 3 coincident relations of mates for one. Okay, it's like a combo mate. Okay, so that's for the first setting. The second thing to take into consideration is that when we mentioned mates in the CSWA exam, we only mentioned the standard mates, but now we can also talk about the advanced mates. So the same thing I mentioned earlier. The exam is only going to test you on these two, let's call them like types of mates, the standard mates and the advanced mates. If you want to use the mechanical mate, that's fine. I would highly doubt that you would need to use one of those in this exam. But if you need to, then by all means, go for it. The exam can be solved by only the list of topics that are listed on the exam web page. If you use anything higher than that, that's fine. But know that there's always going to be a simpler solution that does not require using that feature that you used, just like the segment command, for example. If I'm not mistaken, it is not listed in the CSWA or CSWP list of topics, but that doesn't mean that I can't use it, right? Now, here's where the major difference always also comes: movement. So I talked about this in the CSWA exam preparation session when I mentioned that movement is something that you do for yourself, just to make sure that you've set up everything correctly before fixing everything as the exam wants you in order for you to extract some information. Well, guess what? Not anymore, because in the CSWP, the professional level, you're a professional. So we can't let something like this slide. You see this intersection? You see this? Did any of you notice something like this before? I highly doubt that, but the exam will not. The exam will test you on pretty much all of these things. So it's really important that you also pay close attention to your interferences, your collisions, stuff like that, to make sure that everything is designed as it should be. Now, sometimes those collisions might be intentional and sometimes not. So it might be something that you assembled incorrectly, or it's something that the exam is actually testing you about and seeing if you're going to notice or not, and so on. So by all means, just pay close attention to something like that. If you have any intersections, if you have any collisions, know how to figure them out, know how to find more information about them, and so on, because this is also something the exam is going to expect from you. Not just the exam, but as a professional, this is the standard that we will put you at. This is where you should be in terms of skills and stuff. Okay, so that pretty much sums up the assemblies and the third segment of the CSWP. That takes us to the exact extracting information part, where it's just pretty much the same as the CSWA, pretty much the same for all other exams. You've got two things which are basically both in the evaluate tab. You've got the measure, and same thing. You can either directly get it from the measure command, or be someone like me who wants to save a couple of seconds, and then just glance very quickly at the uh, status bar in the bottom right corner, and there you might also find the information you're looking for without the need to launch a new command like the measure command and stuff like that. On the other hand, the mass properties, this is where it's pretty much the same as the CSWA, but remember, in this case, when it comes to centers of mass and stuff, it's, if I'm not mistaken, always defaulting to the origin of the assembly. Sometimes you would want to have a different reference. Let's say you created a separate coordinate system or something. So that's also something worth considering, worth paying attention to. If there's another coordinate system, you have to also know how to set it up in terms of referencing that coordinate system instead of the default origin. Once you have something like that set up, you're pretty much good to go to get your values from here, enter them in the question or as answers in the Tangix tester, and you're good to go. Okay, now hopefully this is more than enough for you guys to like tone your skills a bit and be ready for the exam. I've always put this slide as like the highest standard slide of this session. This whole session can be disregarded, but this slide cannot. So the first thing is, now we're not talking about the CSWA where you have like a 1% chance of error. We're now talking about a 0.5% chance of error. So if the answer is 100 grams and you enter 99.5, that's fine. 99.4, unfortunately, that's a wrong answer. Now, the other thing is, please do not follow the attached images. Any images put in the question are only for your reference. These are not images for you to like trace or like take a screenshot from your model and put it on top of that and see if there's any pixels of difference between them, because believe me or not, I've found people who sometimes do stuff like that. Just understand that those images are there for the references, for the values in them, but not for accurate dimensions to be taken off of them. So if the dimension says 100 millimeters, that doesn't mean that when you put it on your device and design it and put it as 100 millimeters, it's going to be the exact same size in terms of pixels on the screen as the exam question, because pretty much they have like a one model per part, and the values can change, but the model, they're not going to save a new screenshot for every single guy who takes the exam. So yeah, that's pretty much it. Focus on the information that you take from the images, not on the images itself. And last but not least, assume nothing. If the exam tells you do this, then do that. If it doesn't tell you to do it, then don't. If you assume that the exam would probably want you to do something, unless it specifically mentions it, then don't. Usually, this is when you would make a mistake, because I'm actually speaking from experience here. When you start assuming stuff, that's when you probably start missing information that the exam is giving you, whether it's something in the images or something in the question text, just for you to affirm the idea that you have in your mind. So it's better to not assume anything unless it's specifically mentioned in the exam or shown directly in the images that you have for each question. Other than that, the next step is to open the Tangix tester, the same tester that you took the CSWA exam on, and go from there. Now, let me see if anyone has never used this tester before. Let me know in the chat if you're all familiar with this software. We can skip this portion. Let me see. Okay, I see many people saying to skip it. Well, pretty much everyone here was on the. Hey, we have one over here who's not familiar with it. Okay. Okay, so I'm going to cover it very, very quickly. So basically what you have to do is go over here to this website, 3dexperience.virtualtester.com. You go through there, you go over here in the top right corner, and you download Virtual Tester. okay, or the Tangix Tester Pro client software. When you download the software, you will have this file. Okay, you can launch this file. It's a very small file, like it's a couple of megabytes. You obviously have to read all of this and then click agree. And as you can see, it's just like 30 megabytes of size. It's not really that big. When it's installed, it will, let me not run it and go once again to the desktop. You have this folder. Okay, forget about this folder over here. This is the file that you would use. This is the software itself. You just run that, and every time it runs, it would save this log file for you. This log file is for just in case that you had a crash or anything, you can submit this file to the certification team for them to verify your claims. And if you had an issue with the software or something, this is what's going to prove it. If you don't have an account, you can create it over here. I prefer if you created it from the website, not from here, because after you create an account, you still have to verify it first through an email link that is sent to you. So it's better to do it from the website, the same website that you just downloaded the software from over here. Okay, just create an account from here. It's the same thing. Since I already have an account, let me just log in real quick. And please don't look at my password. I said don't look at my password. I see you over there. Anyways, once you log in, you would find that this software is the same for pretty much all these brands of SolidWorks Soul Systems products. What we're interested here is the SolidWorks. You go over here, go to the, let's say that this would say like CAD design. Anyways, you would just click start the exam, choose the language, start the exam, and be good to go. Obviously, I'm not going to start it with you right now because I've already passed it before, so it's not going to be shown over here for me. But yeah, that's pretty much it. Now, once you pass the exam, you can log in over here, and you would find yourself over here. Hey, we have an Egyptian here. I just passed the CSWP exam while we're talking right now, so this is so cool. You would be listed in this latest certifications issued section. It's so cool to go and take a screenshot of that part. And then if you go over here to your account, you would find all the exams that you have passed, where you can, let me see, where's my CSWP? It's over here. You can just click here to download the certificate and click here to download the logos that you get. You can also see this certificate ID, which you can use to verify any exam. So if you go over here to this validate certificate, you can enter the certificate ID, enter these numbers. These are so hard to read. I think I'm writing them correctly. Let's see. And it's going to say this certificate is valid. It was issued on the 23rd of 7, 2020. So a bit over 5 years ago, and validated on the 2nd of August, which is today. Okay, so this is how you can validate pretty much any certificate out there. With that out of the way, the last thing I'm going to mention about this is this directory, the directory of certified users. So over here, you can go over here to select a certification, maybe like the CSWP. As you can see, we've got 270,000 certified professionals worldwide. Let's see how many of them are in India. I'd expect a lot. Wow, 27,000. We're talking about 10% of CSWPs worldwide are actually Indian. But here's the thing that I don't like. You see this? Let me just zoom in a bit. So we have 27,000 CSWPs in India, but only 9,000 are listed in this directory. Okay, and the reason for that is that if I scroll down over here, it tells you that only users with the show in user directory option in their profile setup would be listed here. So if I go to my profile once again, and I go to my settings, you see over here, this list in online directory thing. Well, make sure to have it set to yes, because that is the only way that I can come over here and search for you and say, okay, let's search for people through their first name or through their city. So let's say, for example, where is Bengaluru? It's in the B letter. So there it is, Bangalore. Okay, some people write it Bengaluru, whatever. It is here. I can find you. If you don't have it set up like that, I can't find you. So it's going to be good for you that you have the exam, but bad because no one can find out that you have the exam. Okay, had the certification. So so let's say, for example, I'm looking for someone whose first letter is letter. Let's go with letter P, for example. So if I scroll down a bit, I think it's going to be over here. A B C D S T. Oh, I should really revise my ABCs. Where is it? I mean, come on, there it is. Wait, oh, ooh, interesting. There's two Prasad Adigas. Cool. I've never known that before. Well, Prasad, did you know that? Wow, that's so cool.
This is the
Anyways,
first time I'm also looking at it.
cool. Well, anyways, we can know, for example, that which of them is the Prasad we know, because they also have their city set up. So let me find out where it is once again. So here, Prasad is mentioning the city is Bengaluru. So now I can see that Prasad has all of these certifications, right? And he also has his LinkedIn, his Facebook, his Twitter. So I can reach out to him to maybe ask him to work for me or ask him to present for my user group, stuff like that. I know it's not this person because this person is from Delhi, so that's another place, and so on. So let's say, for example, this guy, he has his YouTube. Okay, this guy over here, for example, he doesn't have any contact information. So even if I want to reach out to him, I can't because he doesn't leave anything other than his name, his location, and his company. So yeah, it's really important for you to fill out this information. Don't fill too much. Just make sure to enough for people to reach out to you throughout whatever or websites or whatever means that you would prefer. For example, I think I only have my LinkedIn. I don't have anything else. That's because that's how I would like people to reach out to me. But yeah, this is pretty much it when it comes to the certification center. Now let's end it with resources. Now I always like to mention free resources. So all of these are going to be free resources. There are many paid resources out there, but I'm always making sure to provide the best resources out there that you don't have to pay for, that would still get you pretty much most of the way there. Okay, so the first thing obviously going to be the built-in tutorials inside of SolidWorks. These are not tutorials for revision, more like tutorials to learn about the tools itself if you're still learning SolidWorks. But the other point as well is the same thing. If you're still learning about the tools, if you're not yet CSWP ready, but you want to make yourself ready, then start with the built-in tutorials or go to mysolidworks.com. So mysolidworks.com, this is the, as it says, your place for all things SolidWorks. Okay, so you can create an account. It's free. It uses the same 3D experience ID that you might have if you're on the user forum. And from there, you can go over here to training. And from training, you can go to the catalog where you're going to find the whole list of courses. Now, if you just have an account, it's not linked to anything, you would be a guest, right? So that's going to open to you some content. If you have an account that's tied to a company, your company is, let's say, for example, it has an active subscription of SolidWorks. In that case, you have a standard account, and a standard subscription would give you access to like 55 learning paths, as you can see over here. So you've got things for the CSWP sample exams, other exams as well, preparation courses for multiple things. I can search here to go like CSWP. It's going to list all the learning paths that I would be interested in for something like that. So for example, if I list by learning path, there's the exam preparation course, and there's also the sample exams. So you can check both of these free learning paths to prepare yourself before sitting for the exam. Now, the last thing is the sample exam. Okay, and this is a PDF. It's basically a PDF that you can download. It looks like this. It starts by like the basic information that we also found on the website, WP website. Also tells you how to take the exam, like download software, stuff like that. And then if you scroll down a bit, here are the test questions where it actually goes through the exam itself, the sample exam, and tells you, okay, design something like this, modify it like that, and here are the questions, here are the answers, and so on. And at the very end, you would find the answer key, which shows you the answers. So make sure you also revise by checking those out. Make sure that your answers are correct. Now, I would prefer if you actually took this exam from the virtual tester, not from this PDF, because although it's the same question and same answers, it gives you a better understanding of the exam setting. Now, if you already passed the CSWA exam, which you don't have to, you can just go straight ahead to the CSWP, totally fine. If you do that, then maybe you're already familiar with the certification environment. If you're not familiar with it, then by all means, take the sample exam from the virtual tester first, just to prepare yourself for the exam setting. Now, this sample exam is only for segment 1. There are no sample exams for segment 2 and 3, at least not officially. So this is also something to take into consideration. And at the very end, you've got some FAQs, frequently asked questions, what to do if like the internet connection failed or the software crashed or stuff like that. So it's also good to give this a read. Now, the last resource, journey to these certs. Okay, so this I think I've shared this link multiple times before. It's like a series of articles, each about a certain exam of the mechanical design or the CAD design lineup. There's an exam or an article specifically for the CSWP exam. I created this like I think it was like 4 years ago. So yeah, so it's still referencing the old logo and the old CSWP-MD or mechanical design name of the exam. It's pretty much the same thing, just that they renamed the exam to be CAD design instead of mechanical design. Anyways, here, this is what I'm talking about. You can either take this as 3 separate segments or one whole mechanical design, or in this case, CAD design exam that's 3 hours and 20 minutes long. And I think this is what you would get from this session, if I'm not mistaken. But this article lists like every single segment on its own. You'd find some tips and tricks every now and then, and it basically covers most of the things that we talked about today, as well as the resources at the very end. This is for people who prefer like textual information instead of like visual information. And as you can see over here, this is the sample exam for segment 1 that I mentioned. So as you can see, it says free exam. You can take it for free. Once you log in, you're going to find it over there. You can take it for free and test yourself before sitting for the complete exam. And then you've got some general tips and tricks, things like changing the interface. If you want to add keyboard shortcuts like I do, you can also check out this one, which is to create a new file for pretty much every question, just for you to be able to come back again to any question in its state that you left it at, just in case you wanted to revise or modify something. Okay, so with that out of the way, that's all for today.